Hello, everyone. My name is Tony Jolly. I'm a rental associate here at Rayco Rents. Thank you all for taking time out of your busy schedules to join us today. Our presenter today is Komi Toviawou with TSI. He's going to give us an in-depth look at advanced sound and measurements using a sound level meter, specifically the TSI SoundPro. Some topics he's going to cover today include Octave Band Filters, looking at the different look at the detection management software, otherwise known as DMS, and we're going to take a look at setup and data interpretation, along with how to maximize the value of your surveys with optimal DMS configurations. While we're doing this, we'll also highlight some important parameters, when they might be useful, and what they might consist of. Komi is a product specialist at TSI focusing on occupational health and safety instruments and has been a part of their team for about 3 years now. Komi has been a great resource for Rayco Rents, providing technical insight to all of their TSI's products. Whether it was at a conference or an AIH event, it was always nice to have a friendly and reliable face that knows their equipment very well and at a deep level, such as Komi and all of TSI's colleagues. Since we have a large number of attendees today, everyone will be muted, and we do have a chat box that you can use to ask any questions or leave any comments. And if we have enough time at the end of the presentation, we'll try to answer as many as we can. About 1 or 2 hours after the webinar today, we will send a certificate of attendance along with a recording of the webinar. If you don't receive this, feel free to send us an email and we'll try to get that to you as soon as possible. Let's see here. The webinar will be posted on our website for you to view at any time. And at this point, I'm going to turn my mic over to Komi and let him take the lead. Welcome, Komi.
Thank you, Tony. Thanks for that introduction. Hi, everyone. I hope everybody can hear me okay. If not, just let Tony know and we would advise. Today, we're going to go over some of the noise sampling methodologies that we can use a TSI Quest noise sound level meter, rather SoundPro, to use. Specifically, octave band analysis, background noise, community noise sampling. Third octave band was a highly requested question, as well as time responses, mainly the impulse responses versus peak response, and when to use those, right? So some of this information may be familiar to some of you, but my hope here is that everybody takes something away from this session by the time we conclude. Okay. Now, I've been told that the crowd that we have today is is very much familiar with noise sampling already, right? So some of the noise standards, exchange rate, and some of the typical acoustic measurements, I will not be going into much, great depth into, to leave time for us to sort of talk about some of the topics that seem sometimes too intimidating to address, right? Now, today we're going to cover noise, workplace noise fundamentals, noise standard, exchange rate, and noise dissipation. We'll also go over noise sampling and common mistakes, how to select your noise range, and how to, depending on the application, change the instrument range. The weighting network that most of you are familiar with, if not all of you, but we'll look at how that affects the measurements and the results that you get when you take noise sampling. Calibration is another one. We'll also look at time responses, octave band, and like I said, community noise sampling. Now, before we dive deep, the key steps and best practices for sampling noise in a workplace. Number one would be preparation, right? Placing the the instrument in an area that does not disrupt the space, right? The placement of the instrument alone sets you apart from everybody else. Because oftentimes, and I've done this myself, you know, you set up an instrument and you may not find it where you left it when you get back, right? Or you may not find it at all. And that has happened numerous times to our customers, and even including myself. So setting up the instrument in such a way that if you're going to need a power source, that your charging cable does not become a hazard, you know, a tripping hazard rather, because that would entail somebody removing it from the space. Planning ahead for the task at hand is also something very very overlooked in noise measurement in the workplace, because it directly impacts how productive you are and how effective your recommendations are going to be, right? The survey application, right? Whether should I use a noise oximeter or a sound level meter, right? That should be determined ahead of time, because there are different applications. You're looking at an area monitoring versus a personal monitoring type of thing. And the instrument setting, all the way from the weighting network to the time frequencies and the instrument range. Octave Band analyzer, right? Again, a lot of you have an Octave Band analyzer on your SoundPros, but often you don't know how to take advantage of it, or you don't know what other applications you might be able to use it in, right? And then we'll cover calibration, pre-calibration, post-calibration, why those are important. They might seem trivial, but they can skew your measurement if not done properly, right? And then annual calibration in factory, of course. Now, noise regulation and standards. Again, we won't spend too much time on this, but knowing the regulation that we're collecting, you know, the data for is where we should start. Whether it be the OSHA regulation, MSHA, or something we want to. I had customers who, for example, would put on meter 1, they'll put an OSHA hearing conservation or OSHA permissible exposure limit, and on meter 2 they'll put their own custom type of settings, right? Because they want to investigate the workplace not only according to OSHA, but maybe more conservatively according to some of their own company policy, if you will, right? Now here's some of the exposure limits when it comes to the duration per day that a worker is allowed to be exposed to noise in a given environment, as per OSHA and European directive side-by-side comparison. Again, a lot of you, if not all of you, are already familiar with this, but it's kind of custom to start with these before diving into the topics. Now, let's address the instrument range conversation. Now, I put a picture of a tree on the slide to illustrate this, and I think it's one of the most effective ways to do so, right? Now, if I wanted to take a photo of that tree, and that is, right, I took a photo of that tree, but what if I zoomed in all the way in, took a photo of that bird, which is a partial photo of that bird, versus making sure to capture exactly that bird that's inside that tree, right? So on one hand, you have an underload, right, of the whole tree. You're sort of undershooting, if you will, or overload. You are sort of zooming in too much, right? So you're not quite capturing the picture of that bird, versus an optimal picture, which would sort of have the entire bird in the frame, right? So you can apply this concept to noise as well, right? Because not setting up the instrument properly will really, we'll see later how SoundPro can tell you whether or not you were overload or underload, and the percentage that it attributes to that. But really, that alone can skew your data from the get-go, right? Not knowing to do that can skew your data. Okay. Now, on the actual instrument, this is how it translates. On the left-hand side, you have a broadband sound range from 50 to 140, right? And on the right-hand side, you have this is an octave band screen, by the way, and again we'll get into all of that pretty soon. But you have two different ranges that are displayed. One that gives you just the broadband, and the other one that gives you the octave band. But both of them allow you to select or change the range of the instrument. And you can do that by pressing the up-down buttons, up-down arrows, if you will, to adjust the range. So you can go all the way up to 140 or all the way down by pressing that button. Now, to effectively select your range, a rule of thumb is to, and you can see it on this slide here, is that the red circle is where you see the range sort of changing, but the yellow area there is where you want most of your bars to be in. You want your, and again, this is the octave band for those of you who have octave band on your instrument. You want all your bars of the octave band be in the middle of the screen there in the yellow area, right? That's where you that's how you can tell that the range is optimal for your measurement. Now, you also need to kind of understand what it is you want to sample for. Now, if I'm doing a sleep study, I'm not necessarily expecting a 120 decibel noise, right? But so the application directly ties into how to the range that you select, right? So you have industrial and air conservation range would be obviously between 80 to 140, and 80 because obviously the OSHA standard has a threshold. So measuring under, anything under that threshold would be irrelevant, right? And you have, applications like community noises or background noises where you don't expect anything above, let's just call it 40 or 30, right? So selecting your range appropriately would do that. You can actually go ahead and sort of, for those of you who have the SoundPro, go into the Octave Band menu and start playing with the up-down buttons and see how that affects your measurement, your reading. Now on the screen on the side there, you get to that screen, by the way, by pressing the enter button, the center enter button from this screen. You get to this screen by pressing the enter button, and then you see that OL, that's the overload. That's the percentage of time that the measurement was over the selected range, and that's a very minimal, very little overload, 0.05%, right? So the instrument tells you how much you've been above the selected range, right? Now let's get into the weighting frequencies side of the conversation, right? Weighting frequencies are important because noise is measured for different reasons, right? Sometimes, most of the times, it is measured to preserve hearing, for hearing conservation. So we ought to know, because human hear between 20 to 20,000 hertz, right? That's the spectrum of our hearing. Although we don't hear the same way across all that frequency. So we ought to know what are the frequencies that we want to prioritize, and what are the ones that we want to discriminate against, right? And that's where the weighting curves come in. So think of them as weight, but they're frequency weights. So you measure sound with no weight, which is Z weighting, and then all of a sudden you apply an A curve to it. So the A curve is going to come in and then discriminate against the very low frequencies, right? And give you sort of just the upper higher frequencies. And the C weighting does a similar thing, but it doesn't discriminate against lower frequencies as much as the A frequency does. And that serves a different purpose, a different application than the A frequency. So again, the Z frequency will give you the flat response with no weighting, no zero weighting. The C frequency would give you a little bit of discrimination than the Z would do, but give you more of the lower frequencies than the A frequency would, which is mostly used for hearing conservation or to choose the appropriate hearing protector, right? Now, you go from a weighting frequency network to a time response. And again, we'll see later how all of that can affect your measurement and how that ties with the octave band analysis measurement as well. Now, time response, you have the same way the weighting frequency work. You have a choice to select between, in most cases, 3 time frequencies, time responses rather. Slow time response will give you a 1 second rise and fall. This is a reaction time of the meter, right? 1 second rise and fall, and that's typically used for occupational noise measurement, including extremely, elevated short-term noises. Most of the time, this is the by default the setting that your meter should be in. Fast response would give you a faster rise and fall reaction time than the slow at a rate of 125 milliseconds, and that's for rapid, fluctuation sounds. But OSHA recommends using slow rather than fast response for occupational noises. Okay, now here's where it gets very interesting. Impulse response is a 35 millisecond rise, which again, faster than fast response, but it's 1.5 second fall. So it picks up the noise faster, and then it takes 1.5 second to fall. So what that means on your instrument, when you set up the instrument to react this way, let's say you want to do it right now, or after the webinar, you bang something on the table, you see a rise on the screen of your SoundPro, and then it decays a little slower. So you can go from 100 to 90 to 95, 80, 70, and so forth. On the contrary, if you were to put it on slow response, you can get a rise of however high that dB level was, but it will drop after a second. Even better, if you do a fast response, it will drop that much faster. So an impulse response, as it relates to your instrument, would give you sort of the residual sound waves after that impact or after that original sound versus the slow and fast response. Now, peak response is a totally different circuit apart from the other time responses, right? And peak response is the fastest of them all. It's 50 micro, right? Not millisecond, 50 microsecond rise and fall. And it's for measuring the highest sound pressure level available. So again, in most cases, you would use peak response over impulse because peak would give you the highest sound pressure level available compared to impulse. And I know that, we call impact noise or impulse noise, and when we see the impulse response, we tend to set the meter that way, but it's not the correct way to go about it. Okay. Now more on the peak responses. RMS versus peak, right? When there's very high amplitude or short duration of peak sound, like a gunshot, the RMS, the detector cannot accurately track the level. So the diagram over here shows you the difference between the peak response, which is far higher than what the RMS max would display or show you on your SoundPro, right? Here's again more details about the RMS. So RMS is sort of averaging the 1 second response of the fluctuations, impulse fluctuations, right? And averages it out. So you'll see an average maximum that is far lower than your absolute peak response, right? Now, let's take all of that and understand how to use Octave Band and what the differences are as it relates to Octave Band. Now, Octave Band, in most cases, sounds is not pure tone, right? It's rather a mix of different, several frequencies. So knowing the components of all those frequencies is important. In fact, it's ideal to know the components of all those frequencies. So here you have a microphone. This is the top of the SoundPro. That microphone takes the sound wave, applies a weighting network to it, put on a response circuit, whether it's fast or slow, and then depending on your instrument, you have a broadband value or you have an octave band value, right? Now, in most cases, you would want a Z weighting octave band, right? You would want a Z weighting octave band because that's the true value of that dB level in that specific band. Because remember, the Z weighting is no weighting. You're not weighting the frequency. So no discrimination on the frequency band, right? But there are applications where you might want to change the Z weighting to the A weighting or the C weighting, for example, on the octave band. Applications such as background noise, applications such as hearing protector, how to choose a hearing protector, and we'll get into that again shortly. But you can already tell how important the octave band analysis is, and then 101 versus 103 would be our next topic of conversation. What happens on the 101 octave band is that you take a signal of noise, and then you apply different what do you call it? You put it into different bands. You put it into bands of 31, 63, all the way to 8 kilohertz. Now, these values are actually center frequencies, right? Because when you think of a band, this is the horizontal axis. If you go from 0 to whatever number, and you think of this as a band, so this must be a value, that must be a value, and so forth. So the frequencies that we have here, these are actually center frequencies of the band, of each band, right? So that's what the 101 octave band is. We take a noise signal, put it in terms of frequency bands, A bands, and then we take the center frequency of that. The 103 octave band takes that a little bit further, right? So you have all these frequencies, including the one we saw earlier. So it simplifies the spectrum a little bit more than the 101 did. So in turn, it's giving you more information than the 101 did, right? Now, I'll be honest, in most cases, 101 octave band will suffice, okay? In most cases. The cases where you would use 1/3 octave band are, as you probably already noticed, would be where you need the very low frequencies. Because this starts, for example, at a 31 or 63. Some meters would only give you 63, where the octave, the 103 would go all the way to 12 hertz and carry that all the way past the 8K that the 101 gave us, all the way to 20 kilohertz, right? Now, a little recap on the octave band on the sound level meter. And again, a lot of you probably already seen this or know this, but you go from broadband to octave band 101, and when you press the enter button on your SoundPro from the octave band menu, you get to the table. So you go from chart to table. That gives you the actual values of each band. And then again, you get to the, by the same click, you get to the next screen, which gives you the, what we call the dosimeter tab, because it gives you doses or P dose or TWA that we use on noise dosimeter standards, right? Here's how the octave band, the 1/3 octave band looks like. It actually looks like on the SoundPro, and you can see how granular that those bands are versus the 1/1. So nice side by side to kind of compare the three, right? Now let's talk about applications. Now, something you probably already noticed here is that the 101 versus 103 are basically the same applications, meaning you can use a 101 octave band to do industrial hearing conservation, general workplace, office, hospital, community noise, environmental noise, criteria curves, and audiometric booth. But ideally, the 1/3 would do everything else from the general workplace all the way to speech intelligibility applications. So if I only had an industrial occupational hearing conservation job, I'm better off, or I can get away with just using 1/1. But if my application spans across community noise and environmental noise and everything else besides this would be a better option. Although you might get away with, using the 101 to mitigate some of these applications, right? Now, what I want to talk about next is the loudness and hearing loss. This is what's called a loudness contour. You probably already know this, but humans don't interpret loudness the same way across all frequencies. In fact, we are more likely to think that a low frequency noise is louder than a high frequency noise, right? And right here you see that for high frequencies, adding 1 dB is somewhat not noticeable. 3 dB is just perceptible. 5 dB noticeable. 5 to 10 dB twice as loud. 10 to 20 dB will be 4 times as loud. Think of exchange rate or doubling rate there. You can tell. On the low frequency, on the other hand, you go quickly from 3 to 10 dB that it will be twice, I mean, 4 times as loud for low frequencies. So that alone goes directly into how we see or how we view the octave band data, especially as it relates to the hearing conservation applications versus the community noise or the rumbling or hiss, sounds in the background or server rooms, for example. Now, how do we apply octave band to hearing protector attenuation methods? You have a good, better, best type of scenario here. The NR, which is a noise reduction rating, SNR for Europe, is the sort of the good category, is in the good category here, because it uses a simple formula to reduce or to determine the attenuation of a particular hearing protector. The HML, the high, medium, low, or some would call it the C-A that the SoundPro provides, is the second best method, right? The better methodology to determine the appropriate attenuation. And the octave band will be the best method to effectively determine the appropriate hearing protector for a particular worker. Now, I would like to caveat this because the octave band we're speaking of here would be ideal on a dosimeter, right? But the octave band on a sound level meter, as long as it's collected appropriately or correctly, can give you enough information to understand what hearing protectors you should choose. Now, I picked a few spec sheets from hearing protector manufacturers to kind of elaborate this term. Now, the top one, the blue one, is a European manufacturer, and you can see here it's a SNR, a 24 dB SNR, and an HML of 27, 19, and 18. Here on the other hand, you have a US manufacturer, which gives you an NRR, right, for each model. Each model has its own NRR, but you also have the attenuation by frequency. So at 2000 hertz, I have the mean dB 35. Then I have the standard deviation of 2.9, right? So if I subtract the 2, I get my attenuation in this band, in this frequency band, which is different than my general NR provided, right? And again, back to the loudness curve, we don't hear the same across all frequencies. So knowing exactly what attenuation I am getting or I can expect in each frequency band can be useful, right? And that's why it is the best methodology to use to determine hearing protectors, right? There's an actual formula that you can use. There are plenty of calculators always also online that you can use to calculate this. You might also wonder, why would someone want to calculate the effective or the appropriate hearing protector to administer? And that is because you can actually not only underprotect people, but you can also overprotect someone, right? Overprotection means that people may not be able to hear important warning, like a backup truck, or a buzz alarm, for example, right? So here are some of the applications of octave band analysis. You have noise control engineering, right? When you measure the frequencies responsible for the overall noise, you can change the structure or of the workplace, right, to reduce the noise impact. Audiometric boot testing is another one, right? Because it ties directly into, and this is something OSHA also recommends employers do. Every employee should be enrolled into a hearing conservation program, and also participate in audiogram or audiometric boot testing at the cost of the employer, right? So you can take the audiogram, look at what frequencies are more sensitive to that worker, and then along with the Octave band data, you can appropriately sort of follow the progression of their hearing, right? Now, community noise. When it comes to community noise, the SoundPro can provide you two different data points. Now, the LDN, the level day night, versus the CNEL, they're essentially the same sort of measurements, except the measurement that you take for the LDN, 10 dBA penalty is applied to nighttime levels between 10 p.m. to 7 a.m., right? And that's according to the EPA standard for a 24-hour average noise level. So any noise, every 10 BA, every 10 dBA in between 10 p.m. to 7 a.m. Gets penalized, versus on the CNEL, community noise exposure level, you have the same 10 dBA level, but also a 5 dBA between 7 p.m. to 10 p.m. So you have an evening and nighttime type of a scenario going on here versus a purely nighttime on the LDN side of things, right? And you can easily access that by pressing the center button from the Octave band screen and navigating left to the screen that gives you this community noise data. The other piece of information that the SoundPro can give you is the exceedance level, right? Exceedance levels represent the percentage, the percent of runtime that was spent above a certain decibel level. For example, L40 to 73 dB means that 40% of the runtime, the decibel level was higher than 73 dB, right? So this is very good information. Imagine running a study and knowing not just what the maximum levels were or what the peak levels were, but what the percentage spent above a certain level also is, right? Now let's talk about a room acoustic quality. Too quiet, right, versus too loud. Workspaces can be too quiet or too loud. It can be workspaces or offices. Too quiet would destroy the acoustic privacy. Or too loud can induce hearing damage or interfere with speech. And too distracting, for example, rumbling or hissing, can also distract workers in the environment. So for that reason, there is an application to determine the appropriate noise levels in an office environment, for example. And that's where we get into the NC curves, right? NC curves, the criterion curve, is another option to display records of noise behavior in a certain room environment, right? So the NC curve has a spectrum of frequencies, and this is a single number NC standard that allows you to effectively determine how loud your room is. So if you apply the NC25 to your meter, anything above or anything below the NC25 will not be heard if that's your standard, right? So these lines are standardized, and you take measurements with SoundPro to compare against the standard, right? And here's how exactly translate on the meter. So you can see that in every band, you either pass or fail. And when you pass or fail, whatever your score is, you have in this case, you have a 10.7 dB fail in this particular band. So this is an NC30 score of 10.7 dB above the NC30 curve, right? So you can skim through the entire spectrum to determine what those levels are as it relates to the NC specific NC30 curve. Now the NC, generally speaking, applies to HVAC room and building acoustics comparison. But there are other curves that also contribute to noise measurement in different districts or different countries, but also different standards. So depending on the application and the standard you follow, you would choose the appropriate NC or criterion curve to use, right? Now, some of the sampling strategies and equipment placing can be determined by following the physics of noise, if you will. Now, when you step away from noise, obviously you hear less of that noise, right? So noise decay at a certain rate. And we just happen to know that that decay rate is 6 dB every time you double the distance away, right? Now that 6 dB is in a free field in the environment, meaning there's no reflective surfaces around. There's no sort of roof close to the ground, or there's no walls. But if you were to take the same measurement in your garage, for example, you will get a consistent noise decay, but not at 6 dB, right? You might get a 2 dB or a 3 dB decay every time you double the distance stepping away from the noise source, right? And you can use this into your applications to change the way people work, for example, right? To apply administrative controls and so forth. The doubling sound source is also, or the noise addition is also a good rule of thumb to keep in mind when it comes to mitigating noise in the workplace, right? We don't add noise dB levels the same way we would any number. 100 dB plus 100 dB is not a 200 dB, but rather 103. Assuming that our exchange rate, which is our doubling rate, right, the rate at which sound pressure is doubled, is 3, right? So if we choose a sound pressure level doubling rate of 3, then 2 equal sounds will produce a 103 in this case, right? And here's a little recap of how that math works. But for most of you, this is just a reminder, right? Now, what I want to talk about next is something that is overlooked a lot of times, which is calibration. Pre-calibration and post-calibration, right? Prior to measuring your data, you need to calibrate your instrument. And with the SoundPro, you can do so with an acoustic calibrator, the AC300. But what's more important, though, is that post-calibration is a simple verification of the instrument, and it's to make sure that an instrument remained in calibration throughout the measurement period, because temperature can affect your microphone, right? temperatures fluctuations can affect your microphone, and that ties directly into knowing your instrument specs and the conditions in which you should or you can use them. Now, it doesn't mean that in a slightly colder environment you cannot use the instrument, but it means that when you take it from, let's say, a colder environment to a warmer environment, you need to wait for the instrument to stabilize, before starting recording again, right? That kind of thing. So doing this pre and post calibration check ensures that the measurement that you're leaving with it can be trusted. And if you see a difference between the pre and post, then you can take that into consideration. If let's say there is a like a 0.5 dB sort of difference, that can be useful data for you. Now, before I go into DMS, I'd like to speak of something that happened here at TSI, and that is the new Edge 7/8 dosimeter launch. This is a new TSI instrument. The 7 is a standard instrument versus 8, which is replacing the Edge 5. And that is the intrinsically safe instrument. I won't spend too much time on this one because that's not why we're here, but I thought I'll mention it while we all here together. So more information, just contact Reiko to learn more. Now let's talk about DMS and show you a little bit about how certain things can make you more productive using the software. Now, some of the questions, and I won't spend too much time here because I like to get to some questions. Some of the questions that we get sometimes is, I recorded, during a break period, or I recorded, studied, and I'd like to delete it. Well, in DMS, you cannot actually delete a graph, but what you can do is you can select parts of the chart that you'd like to include into your calculation. So for example, I can go over here, and by the way, if this is bothering you, which it does bother me, you can deactivate it by hiding it right here, and then go and select the cursor. I'm going to choose this portion of the chart, and it says selected range. I'm going to select all this information right here. That should be enough. I'm going to come over here and click on configuration. It pops this screen up, and then I'm going to select more of this type of data right here. So essentially what happens is your study is recalculated. Your study is recalculated I have to start this one over. I don't know where it went. Having a little issue with my screen resolution here. Just bear with me 1 second. There you go. This looks a little better. So here's how that's done, and your study is recalculated by let me go ahead and change that. Select some of this. There you go. The data should have displayed over here, and I'm not sure why. I'm not able to see it right now. But there's a video that I made about this, and if you have a DMS instrument, you can try it, give it a try. I might have to close it and reopen it again, but for the sake of our time here, I don't want to spend too much time on it. But you get the gist of how that works. So it gives you the calculated values only based off of the selected areas, right? Now, the other thing that I find interesting to point out to folks is that these little question marks here, right? These little question marks, these are marks that you can use, for example, for quick help. So if I selected that, I could go over here, right? I could go over there, and it gives me exactly just what I needed to know under this, taskbar. So all these icons and what they do and what they mean, etc. Right? This is far better than digging into the 300-page DMS manual. Right? So I find that to be very helpful. For example, this bar as well can be accessed. The help can be accessed by pressing this button right here. And if I bring it up this way, you can see where or how these icons work, and that's very useful tool to have. Now, last thing maybe I could show you here would be the octave band data, right, and how that displays on VMS. So here you can see all the frequency bands and their corresponding dB levels in form of a chart, as well as a table version of that, so you can correspond or associate every frequency band to their appropriate dB level. In fact, you can choose how you want that data to display. So I can do a dose versus frequency, an L average versus frequency, and so forth, right? Or a P dose versus frequency, and so forth. The NC curve, I said that was the last thing I wanted to show you, but why not, right? So the NC curve is another measurement that you can access. I think my screen resolution is killing me over here, but you access the NC curve over here, and with a noise sample, you can get the values of what those dB levels are as it relates to the curve, right? So you not only can tell on the instrument, but you can also access the same information from DMS if you have the NC curve software or firmware, rather, in this case, on your SoundPro, right? So I'd like to stop here and then get any questions that we might have had. Tony?
Thank you, Komi. That was fantastic. I really appreciate you enlightening us today with your presentation. There actually are surprisingly no questions. However, I did have one myself. When you were highlighting that range of the graph, is that
Yes.
only applying to the TWA, or is that also changing the calculations on the averages, peaks, minimums?
Yes. So let me pull that graph up again. So this graph right here, I can when I go in there and I select it, the measurements that are available for that graph. Oops. There you go. Would be TWA dose 8, and you can choose whether or not you want to show the excluded calculations or show in the individual calculations. It's not working here for whatever reason, but those are the informations that you will get on the from the graph, right? From the selected region or the recalculating function.
Gotcha.
Yeah.
There is one question. Are there any limitations to a Type 2 sound level meter compared to a Type 1?
Yeah, so the limitations of the Type 2 sound level meter would be accuracy. So there are some, and application. So in occupational noise exposure, Type 2, in 99% of the time, you would need a Type 2 sound level meter. You can get away with the Type 2 sound level meter. If you take a gun range application, for example, the microphone itself, because of the high peak levels, the microphone itself that is used in those applications is solely Type 1 microphone, right? So it used to be called Class 1 in the standards. It was changed to Type 1, but it's accuracy and noise level that dictates the differences between the two, and application, right? But yeah, most people use Type 2, and that's completely fine, including OSHA.
And would that make any difference if you're using an Edge 7 dosimeter?
If you use an Edge 7 dosimeter, and I'm assuming you're asking because you would sort of use it either in conjunction or as a sound level meter. In conjunction would be ideal. You know, the sound level meter will come first, and then the dosimeter will come next, right? To do an area survey and a personal survey. But to use a dosimeter as a sound level meter, you are trading off a few things, right? The dosimeter itself is not built to conduct surveys the same way the SoundPro is. It does not have the preamp, the same preamp that the SoundPro does, and it's limited to being handheld, right? You can only hold it in your hand because you cannot put it on a tripod, for example, right? But OSHA recognizes that in some cases, folks use a dosimeter, you know, in place of a sound level meter or as a sound level meter. Um, it's not quite frowned upon in the, you know, in the regulatory world.
Understood. Appreciate it, Komi. I really appreciate
Yep.
you taking the time out of your day today to give us this presentation. This will certainly be useful for many users of the sound level meter, especially for our clients here. If there's any other questions, feel free to call us at Rayco Rents 866-RENT-EHS or 866-736-8347. You can also send us an email at rentsconfirmation@raycorents.com. Like I said at the beginning, everyone will be receiving a video recording of today's webinar, roughly 2 hours after this session ends, along with a certificate of attendance. And this will also be posted on our websites, also on our YouTube page for you to view at any time, and also to share with your colleagues. If I kindly ask you to fill out the survey that you'll see here shortly, we'd love to hear all your feedback for future topics on future webinars and any feedback that we can do to improve these webinars for you. Thank you for attending today. I hope you have a great rest of your day.